okay? Nothing that you can do can change this, okay? You can change this stuff, sure, but you can't change this actual reference, neither this address, right? You cannot change that address. The reason I bring it up is because in some languages, you can do this stuff, right? You can actually do this. In C++, you can do this stuff. Why? Because what you say here is, when I create this void function called swap, what I'm going to get in here is I want a pointer to X and a pointer to the Y, or in this case, this is an address of, right? That says, hey, I'm receiving the address of where X is in memory and the address of where Y is in memory. Now I can change those things and they point at new things because I was given the address of their variables, not what they point to. I was given their address, right? So I can go find them and change them. And in Pascal, there was a keyword called var, right? And var says, I want to be able to change that sucker, right? So when you pass that in, I want access to that variable's memory location. So in some languages, you can do this stuff using either tricks of pointers and addresses in C or keywords in some other languages, but Java can't do this, okay? It just can't. Now, it turns out the problem is not as great as maybe it sounds like, right? It's not as great. You already know how to solve it in some other context. For instance, with strings, you know how to do this. But let's say that we have a method called transform point, and we pass transform and we pass in a point, and then this thing actually points this thing to a new point, and then we change this to where our local variable point points to the newly created point object. Well, as we know, that's not going to work, right? We know that that's not going to succeed. So what do we have to do? Here's the concept. We're going to use the thing called x equals change x. And that says, rather than passing the thing in and then making this futile attempt to do something with it, instead, watch what we do. We take in the point, we create this new point, right? And then we return a reference to that new point here. We say, hey, we know that when in this transformation process, we're going to be creating something new. We're going to take your point and do stuff with it and give you back something new. So I need to return a reference to that. Okay, so it's not a void method. It's going to be a point method. This, in fact, this data type here is going to be the same as the data type here, right? Because I'm actually making a new thing in my process. I'm making a new thing. So I'm going to give you back a reference to that. And then on the calling side, you notice they don't just pass the point. They pass the point, and then when they get it back, they reassign it, because they know it's probably pointing to something new. So you pass it as a parameter, but then you store it back in the same variable when it comes back from that call. And that way you've captured, your pointer is now pointing at the new thing, right? By updating P, now we're pointing at the newly returned point. Could be the same point or could be a different point. It doesn't matter to you, right? Whether this thing returned the same point or a different one, you always capture it on the way back in. So the magic is right here and right here and right here. Return the same data type. Then in the call to it, capture that and restore it, right? P is pointing to whatever came back from that. If it happened to be the same point, great. Then I'm wasting an assignment, but who cares? Right? It's just an assignment. It's just copying over an address in memory, right? And if it's a new one, then hurrah, I've captured a pointer to the new one. But either way, I'm golden, right? Does that make sense? It's the same thing we do with strings, right? Because of their immutability. It's the same thing we do with a string. We call string whatever, my name dot to uppercase, and then we store it back in my name, right? If you want the new string, you got to capture it, right? So we've done this all along with strings because we understand the immutability. This is kind of doing a similar thing, right? It's getting around the fact that you can't change the caller's reference, but if you just return the thing, a pointer to the thing, then they can capture that pointer to a thing and then everybody's good. This is the whole algorithmic concept called x equals change x. Don't just call change x because change x is not going to be able to update that reference, but assign it back when you're done. then you'll have what you need. Okay.